All right, so we're back talking about z-scores and how they relate to our normal table, and we're continuing on talking about how you compute whether it's to the left of a z, to the right of a z, or between. That's the three scenarios you get. To the left of is exactly what the z-table chart gives you, so you take the number just as it comes out. If it asks you to do the right of, it wants the other tail end of the curve. So we take our answer, we look that up on our z-chart, take that answer, and then subtract it from 1 to get your answer. So these subtract from 1, and then we were on the between examples. In the between examples, we look up each of our values on the z-score table, get our answers, and then subtract those. So the answer between will always be a subtract of the two values, and that's because you're double counting the tail end of that. To get the between, you subtract those two. So here we are looking up 1.32. If you haven't already, do pause the video on these. I always want you to practice on your own first, and then look up 2.35. Did I already do that? Let's see. 2.35 is 0.9906. Oh, that makes me think I didn't do that one right up there, so I'll have to amend that. That should have been a 4, guys, so my bad. It's easy to get offline, as you might have noticed on these little charts, and I'm looking at it sideways even at that, so move over. So do make note on the last video, I did have a little mistake there. That should have been 1 minus 0.9904. Oh, don't make me have to redo that though, right? That should have been 0.0096 or 0.96%. It's very close to the same answer, but you know, your math program would not think so, so you have to get it just right. Okay, so back to our problem, 1.32. Hopefully I looked that one up correctly. Y'all do send me emails if you notice anything I do need to fix, and I can remake a video. I'm just kidding. Sort of. 2.35. All right, so those are correct. Then I do want to subtract them in the order that gives me a positive answer if I didn't mention that before. So take the bigger one minus the smaller one, and I will get 0.084 or 8.4%, whichever way that question is phrased. All right, next we have more of a reading problem with real values. It makes it just a little more interesting, but we do the same thing. Here we're talking about IQ scores. IQ scores are normally distributed with a mean of 100. 100 is the average. So if you were looking at the little curve I like to draw, the mean is 100 IQ. And a standard deviation, one standard deviation, if you want one z-score, z equals 1, you want up 15 points. So every standard deviation is, it says, standard deviation of 15 points. So determine where you'd fall on percentage-wise, what percentage you would fall if you had 115 IQ. So and it says below, all these belows are to the left of. You know, if you're below something, you're this way. Well, actually, that's exactly z equals 1. But let's not get ahead of myself. I should show you the work. So to do a z-score, that's a raw data. We take the number minus the mean, which is 100, divided by the standard deviation, given again 15. That will give you 15 over 15, which is z is 1. And that's sort of what I was trying to demonstrate here. At z is 1, you'd be 15 points, one standard deviation above the mean. All right, so that kind of confirms that. Then you look up 1 on your z-table. This converts it so you can use the z-table, and you get 0.8413. So you would be in the 84th percentile as a percent. Another below, we do 130 minus 100 divided by 15. So that's 30 over 15, which would be 2. Look up 2 in your z-table, 0.9772. You'd be in the 97th, 0.7 percentile. Another below is 70. So now you're going to have a negative z-score below the normal. So 70 minus 100, that's our calculation, divided by 15, that'd be negative 30 over 15, or negative 2. These don't always have to come out just perfect. I just happen to have made some examples that did work out to divide evenly, but you know, that doesn't always happen. And I get, you'd be in the second percentile, right? 2.28 as a percent when you're below 70. That's the percent that would fall below an IQ score of 70. in this example. All right, we move to the between example. And as we saw above, when you do a between, you do these calculations and then subtract your two answers. So I look up 70. I just happen to have already calculated that, and I have 0.0228. And 115, we did that earlier. 115, let's see, was 0.8413. So you just do those calculations again if you didn't already have those. Then subtract. And you want to subtract the bigger minus the smaller. So I don't necessarily have those in that order, you'll notice. But you subtract those two numbers and you get 0.8185, which will be 81.85% of IQs are between 70 and 115. So most of the data falls in that area. Between 115 and 130, so let's do E part. So 115, I have that number as 0.8413. 130, we did that one earlier, and it was 0.9772. So again, if it says between, we take our two Z values and subtract. That gives me 0.1359. So as a percent, 13.59% would have an IQ that's between 115 and 130. That should be the percent between. And then lastly here, above. Remember, above would be to the right of that we did earlier. Above something. So if we looked at our Z-score as Z equals 0, right at the mean, that's 100, IQ of 100. Over here somewhere, 122.5. When I look up 122.5 as a Z-score, and let me convert that, you subtract the mean divided by the standard deviation. You know, 125.5 is not in our chart. We have to convert it to a Z value with our little formula. We get a Z of 1.5. Then we look that up in our chart, and it's 0.9332. Now, when I look it up in my chart, remember it gives me to the left of. The chart is only from there to the left. So we have to do our own calculation if it asks me above or between. So above would be this opposite tail end. So that's when we take 1 minus our answer, when it's an above question or a to the right of label. And that'd be 0.0668, or about 6.68%. Right here, we'll have IQs above 122.5. All right, the next example, G here, we're talking about our battery, the warranty on our battery, how that they make warranties from crunching these numbers and figuring out what the average is and what the standard deviation is. So it absolutely applies real time to things that you come in contact with in these warranties. And they can count on the large masses falling in this middle being great and even being outliers to being even better than great. But there'll be some that will have less than they expect, and those are your warranty claims right there. So if a breakdown time of this battery are normally distributed with an average mean, there's our mean, it always tells you that, 46 months, and a standard deviation of 8, what percent of batteries can you expect to require a repair or replacement under the warranty? So if we're looking at that little curve, you know, I like to make, here's the middle, that's the mean down the middle. 46 months is the average length of a battery lasting. Average mean life of the battery. Now, they're warrantying it down here below that, so giving themselves a little leeway at 36 months. So they want to know how many of these people are going to have to file a claim. So that's a less than little area. So we'll be able to use our Z-score. We're got to convert these because 46 and 36 are not on our table. They have to be converted. We take the question, which is 36 months, minus the mean over the standard deviation that was given as 8. We crunch that in our calculator. Now here the sign does matter. You do need to subtract in the right order. Whatever your question is, the 36 months is the question, minus the mean, which is given in the problem, divided by the standard deviation. So that tells us it is a negative number, and that does matter because the chart has negatives and positives in it. So you need to make sure you get the right one. I looked that up in my chart, and it says in the table of values 0.1056. So in other words, that would be 10.56% of those customers are going to be calling and asking for a repair or replacement. I think that was the question determine the percent. It asks for it in percent form. So 10.56 would be our final answer there. All right, I got one more for you. One more example. A weight loss clinic guarantees that its new customers will lose at least 5 pounds by the end of the first month of participation, or their money will be refunded. So it's kind of the same question really as the battery. We've got the average customer here given. The mean is the average customer is losing 6.7 pounds, and it gives you the standard deviation. And it's wanting to know who gets to ask for a refund. So who are those unluckies out here? They're guaranteeing 5 pounds. So 5 pounds is our question right here. So who are these people that lost less than 5 pounds? Over here on the less than, didn't work out for them. So same thing we just did. We take our question is the 5 pounders who did not lose the 5 pounds, who was less than 5 pounds. So 5 pounds is our raw data minus our mean is given. Again, it tells you the mean divided by that standard deviation. Standard deviation, I'm a mess there, aren't I? Is 0.81. That is 5 minus 6.7 divided by 0.81. Sorry for the mess. So I crunch that on my calculator, and I get, let me make sure, 5 minus 6.7 divided by 0.81 is negative 2.0987. So I only need, I'm going to have to round on this one since it didn't come out as clean. That 8 would round that 9 up to a 10. Do you notice that? So that's going to be actually negative 2.10, because you know you need 2 digits there to use your z-score table. So that one did require a little extra detail there. So the 8 would round that 9 up, right? So we do need to look up negative 2.10. So I'll look that up in my chart, and I get 0.0179. That's these people right here. To the left of is what the z-score table gives us. Then we move to right, and that'd be 1.79%. Not very many. I don't know that this is real to life or anything, that this really happened, but just theoretically this happened, and there would only be 1.79% of the customers, if these numbers hold true to their data, that would actually be able to say, hey, I need a refund. Well, so then, and I didn't ask it on this particular one, maybe in some of your homework it might say, well, if there's 500 customers, how much money are they going to have to pay out or something? So then you could say, whatever the refund claim is, times it by 500 or something. You could kind of figure out how much money do you need to allot for this possibility. And then back on the example with the battery, however much that battery costs, you may have to replace it. So however many batteries you're selling, you need to account for that percent that might have to claim the refund into your budget. All right, so that's what I've got for you in this section. And hey, this was the last section, the last thing to know for this class. I hope the class has been helpful to you, and you've learned some things that will really come up in your real life, and that you'll think back and say, hey, it was good we learned about that. It's been a joy teaching with you, and please feel free to contact me anytime if I can help with further explanation. Best wishes.